and welcome to JAX 2016. We are here with one of our speakers, Mr. Lawrey. Thank you for coming, for accepting our interview. You will be delivering 2 sessions, is that correct?
Yes.
What is the message of the sessions? What should the attendees retain after your 2 talks?
That Java can be used where latency and throughput are really important. It is used in trading systems and at various investment banks and hedge funds for producing low latency trading systems. But it also means that you can use Java in broader contexts where latency is still very sensitive. It's not something that you have to necessarily move away from just because you need to improve your latency profile.
And one of your talks is about microservices and monolithic architectures, and both have benefits and disadvantages, right?
Yes.
But why would you choose one and not the other?
Well, one of the subjects of the talk is how you can get the best of both worlds. So I explore a design approach where you can create components. These components can be either used as microservices, which is particularly useful in deployment in production. It allows you to give you resiliency and separation of concern between services running in a distributed system. But a monolithic architecture is much easier to test and debug, because you have everything in your process and in your thread available to you. And so with this design approach, I show how you can construct these components in a unit test, debug it in a very simple manner, but then also then deploy them as microservices. Also, it means that it should be, by making the transport optional, it should mean that you use microservices when it makes sense to do so, not because you built that as a constraint up front before you started. So, because if you say everyone has to use microservices, you may end up using it even when it doesn't make sense. If you've got the option to choose one or the other, you might decide that actually these 2 components, they don't need to be separate services. They should be probably joined, and that becomes just a deployment decision.
Do you have maybe an example for that, for a better understanding?
Yes, so one of the things I talk about is, say you've got an upstream component that's taking market data. It has to aggregate this market data in some manner. I use a simpler example where, say, the market data provider is only giving you the bids or the offers separately, and it needs to combine them. And you might have a downstream component, such as an order manager. It has to take these prices and then decide whether to place an order or not. This makes sense to have them distributed, and certainly within a trading system they're often running in different threads, if not different JVMs. However, if you want to unit test this, you don't really want to be creating a framework with lots of threads, because if something does go wrong and you need to trace exactly where the cause of the problem is, it's very difficult in a multi-threaded program to do that. So instead, what you do is you just say, well, for testing purposes, I just want to see that when this component talks to this component, it behaves correctly. And so you wire them up without using multiple threads or a transport. You just see that when one calls the other, it behaves as you expect. Because if it's not going to work without a transport, it probably won't work if you do add a transport, which adds complexity.
Let's get one step further. So, do you have 2 examples, let's say 2 design patterns that we can use that allow us to use these strategies without massive change business-wise?
Yes, so the way I model a microservice as a service is a component with a transport. And so, and that transport should be made optional. So you may not have any transport, you may have a different range of transports, but in particular, the common pattern that we use, and I think most people are migrating towards, is asynchronous messaging. The benefit of asynchronous messaging is that you're not locking in any delays between different services. When you use synchronous messaging, any delay will not only delay the handler of that message, but also the one that issued the request in the first place, because it has to wait for the response. If you use asynchronous messaging, you can have a whole chain of services, each depending on the other, but that doesn't effectively lock up the entire system. You don't have that as a potential outcome. So the two patterns start with a component that works standalone and can be joined with other components with or without a transport. And the other one is to use asynchronous messaging, which we model using an interface. So you take an interface and you have a series of messages. Each message is a method type. Its payload is its argument, and it doesn't return anything. That's what makes it asynchronous, because you're not expecting a response. And so we start by modeling as an interface. Your component implements that interface. It expects to send messages out. That also is an interface. And that way you can wire them together. You can also easily see that no transport's actually required to do that. But then when it makes sense to do so, you can easily add an asynchronous messaging transport.
Maybe you have something to add about your own expectations or surprises even regarding your sessions, your upcoming sessions?
I think probably the biggest surprise is that people find is that we use a transport which is persisted. That means it records every message to disk eventually. It doesn't wait for it to go to disk. So it writes into memory map files. And so the most common question is, oh, isn't that slow? But in reality, what we find is that by recording every message and doing it in a very lightweight way, we get improved transparency of exactly every message that's going through your system. And you reduce your logging, because you don't need as much logging anymore, because you're actually recording every input to every component and every result. There's not really a lot more information you need to record. And we've actually seen, after you put this into the system, that the performance improves. We had one client, they started with a trading system that was tick to trade responding in 35 microseconds, which is pretty good in Java. That's about a 30th of a millisecond, right? But after they put in Tronical Q and they could see a bit more clearly exactly what they were doing, and they removed a lot of the logging that they were recording, it dropped to 23 microseconds, which is around 40th of a millisecond. So by adding a persistence layer, they actually improve performance, which is counterintuitive to most people's experience.
Thank you for the information, and thank you for being here.
Oh, pleasure. Thank you for asking.